Hello there, YouTube. It is me again, and I am back with another topic review for you. If you're new to me, you're new to this channel, new to this playlist in particular, I am a student at the coding boot camp called the Flatiron School in the data science program right now. A little over halfway through the program, actually quite a bit over halfway through the program. And what this whole playlist and series is about is there's like 10 to 12 modules per phase, 5 phases in the boot camp. And for this phase, as a new sort of study strategy, I am vlogging about what I've learned in each module along the way. So this video is going to be over module 30, and there's 31. It goes up to 31 in this phase. There's 12 modules in this phase, of which they started at 29 or 30 or something like that. So there's this, and then one more vlog that I'll make over module 31, which will be a little bit more in depth than I think than this module is. This is gonna be a relatively quick video, because all my videos are like ridiculously long. But anyway, also you might notice if you have been watching my other videos, I have a little bit of a slightly different background. You can't really tell because it's blurred, but I over this past weekend moved out of my college apartment. I graduated college a few months ago, and I finally moved out of that apartment that I was in, and now I'm kind of squatting at my parents' house. And I'm going to finish most of the boot camp here, and then I want to take a road trip down to Yucatan, Mexico, and kind of go hang out and bum for a little bit before I start having to be an adult and get like a big boy job and all that stuff. That's not completely true. Part of why I want to go to data science so I can work remote, so I can go travel like that. Anyway, but yeah, so I'm in a new location. Also, you'll notice my microphone is not hanging out here in my face like it normally is because I haven't set all that stuff up yet. So this will be interesting to see how the audio quality is from just like my desktop. So yeah. We're in a new location, but same song, same course as far as the video goes. Today we are talking about module 30, about machine learning pipelines, grid search CV, and Pickle Files. Let me get my screen to where I'm seeing what you're seeing right now. Cool. So we're here in module 30, ML pipelines, grid search, and pickles is the topic of today. So the first thing I'm going to talk about is pipelines in SciKit Learn. You can see this is the whole notebook. It's not a whole lot going on today. So right now we're just going to zero in on this little code block right here that you see in front of you. So you've seen me do a lot of stuff in the past where I do a bunch of pre-processing on the data, and then I build some sort of we'll just call it a model, but machine learning algorithm, like whatever. So a pipeline is basically a way to pack all that into like one line of code, like you see here. And like all things in SciKit Learn, it's all an object. So of course you have methods that you can call on pipeline objects, same as you have like the same methods you can call on classifiers and regressors and whatever other kind of like estimators and that sort of thing. Pipelines generally the same methods you can call on an estimator, like a k-neighbors classifier or something. You can call those same methods generally on pipelines. So the rough syntax you see here is you have kind of like a list of all the things that you want to pre-process the data with, and then at the end you have the actual estimator that you want to pass that pre-processed data into. So this one's pretty simple. You just have a min-max scaler, and you have, of course, like kind of your labels here for like exactly what each of these objects is. And I think this is not completely, you don't get to completely make up your own. There's like certain ones that should be used with, like for instance, min-max scaler you should always have MMS as your string and that tuple with it. So you have tuples where the first value is just some string kind of labeling what that object is, and then you have like the instantiation of the object itself. So this is, you can see, the same as if I were to do it's not going to autocomplete for me because I haven't imported the thing, but so it's that. But so I have to, all that to say, I need to make sure to have these parentheses here on the back end when you're instantiating those objects. Yeah, so that's what a pipeline is. You can create this thing, and like I said, this variable pipe here is now an SciKit Learn object, and you call .fit on it with the data that you want to pass in, and then you can deal with that variable pipe the same way you would deal with any other kind of model that you built. So that's really cool. It's a way to, you can see here in my annotation I have, pipelines provide a dry way to write model development. What that stands for, dry is an acronym, stands for do not repeat yourself. So you can imagine this is the sort of stuff where, you know, a whole notebook basically can be condensed into this one little line of code here. So it's just, it's a way to, it's not accomplishing anything different from what I've been able to accomplish so far, but it is going to be able to kind of like scale your own like labor up, right? So that you can do more of like those same things. So pipelines are really cool. Of course, it's important to know how to use each one of these things individually. You don't want to just start pipelining everything, but definitely, obviously, a very powerful tool to have available to you. That's weird. I don't understand why, like, sometimes my markdown code just turns all maroon for some reason. So, in addition to these pipelines that you're building, of course, there's hyperparameters along the way that you need to assign values to, like random state here. I don't know if I would technically consider that a hyperparameter, but you know, everywhere you have one of these little enclosed parentheses at the end of one of these objects, there's probably some parameters within there that you can pass in various values to. Obviously, that would can get pretty computationally expensive and time consuming to try all the different variables or hyperparameters that you can, variables that you can pass into your hyperparameters, that sort of thing. So SciKit Learn has this thing called grid search CV, and basically what it is you create a grid of through a dictionary. So imagine like you see this dictionary here, the strings, my keys, imagine those are the column labels, and so this is like row 1, row 2, row 3, row 4, and so on. So SciKit Learn reads this dictionary as if it's a grid, just like a typical spreadsheet type of thing, and it's going to basically search for the best combination of all of these hyperparameter values that are present in that grid. So that's part of the thing. It's not just going to magically find you the optimal like hyperparameter values. It's going to find the best combination of the ones that you provide to it, right? So that's good to keep in mind. But nonetheless, so you define your hyperparameters that you want to explore, the values of your hyperparameters you want to explore, and you instantiate this variable grid search with your grid search CV object. Of course, it has its own parameters that you want to pass in. Estimator. So this is you could do this with just a kind of vanilla estimator object. Like if you just did a k-neighbors classifier or a decision regressor or whatever, you could pass that in there. But you don't want to pass in like the type of estimator you're using. You want to pass in like the estimator object itself, right? So you can see up here, I created this pipe object, which is my pipeline. And then I'm passing that in here for my estimator parameter. Likewise, you want to pass in the variable containing your grid that you want to search. So we have grid defined here as this dictionary. And I am just now noticing, this is interesting, something I should ask my instructor about. This is a single item list. It's enclosed in like the brackets here, and then the dictionary is inside that list. So I wonder if there's like multiple grids that you could, if you could search multiple grids. Huh. That's just a little bit of me thinking out loud. Point being, you want to define your grid and then pass it in to your param grid parameter. scoring. So later, I didn't write the code here, but I could do like, just like you have grid search.fit here, I could do grid search.score, and it will return some value to me. Whatever that score is you're assigning that setting, if you will, here. So if I wanted to do like F1 score instead, this is where I would pass that in at. CV is your cross-validation value. So if you want to, if you're not sure what cross-validation is, I'm pretty sure I've done videos about that in the past, or a video. It's come up at some point or another. But basically, it's a way to resample the data to validate that the results that you got from the tests that you ran on this sample, are like representative of reality. So if you have like 100 observations, and you might take like the first 10 as your test sample and train with the rest of it, see what it gets, and then you'll take the second set of 10 as your test sample and train it with the other, like the first 10 and then the next 70 or whatever. And so you're just gonna take like different splits of different train test splits, and you're going to compare the results of each one of those. Basically, you're going to build a new model for every like validation that you run, and you compare the results with each other. And if they're all like close enough together, like within a certain threshold, usually I believe you use mean squared error, at least for regression models when you're evaluating cross validation. Anyway, it's just a way of like resampling the data you already have in a way that gives you indicates if it's representative of like the other data that exists out in the world that you haven't actually collected yet. So you can validate that it represents the real world without having to go and gather all of the actual data in the real world. So you can do that to different degrees. You can do 5 kind of folds of cross-validation. You can do 10, 15, like whatever. So you're passing that in here. And then you run that code. Imagine this was in like 2 different cells. And then you would have this object called grid search that you could call these methods on. And again, once you run this and you've instantiated this object that you've named grid search, you can treat that basically like an estimator at that point. So the same way you call .fit on, if you just did like KNN equals K-neighbors classifier, K-nearest neighbors is on my mind because that was like the last module we did, or the one before it. And you call .fit on it to fit it to that data, like it's you deal with it the same way you do an estimator object. Yeah. So moving on to deploying model objects with Pickle/JobLib. So first I'm going to talk about like Pickle Files and what they are, and then we'll talk about JobLib, which is basically just Pickle Files. And I actually bothered this time to go and put some commenting in the code here. So if you're looking at the notebook, or you want to go look at the notebook, this will be a little bit more readable. I haven't done that in the past with these because this isn't actually a code cell, it's just like a markdown cell. But anyway, I'm gonna double click that just to emphasize, pay attention to this for the moment. There we go. Okay, so Pickle Files, as I understand them, and I don't know if this is exclusive to Python or if this is like a thing with coding objects in general. Like maybe this works. Maybe there's a Pickle library for JavaScript. I don't know. But for Python, obviously there definitely is. There's this library called Pickle, which obviously you need that. Where'd it go? Why is it running that cell? There we go. Okay, so you import your Pickle library, and similar to if you've ever like read or edited or done anything with like files on disk through Python, this code block will be pretty familiar to you, with this with open as whatever variable you want syntax. So basically what's going on here is we're calling this open function, which is it's going to open a file like on your computer is basically what it does. And you pass in the file path to the file, which here we're creating a new file. This is part why I do this in Markdown and not actually, because I don't want to write a bunch of random like new files on my computer. And then in this, as a second parameter that you're passing in, you're passing in like exactly what you want to do. So the W stands for write and the B stands for binary. So we're writing something in binary, basically, is what that's saying. So sometimes if you're like, if you have a string and you want to save it as a pickle file, then you could just do, well, that's not exactly right. I'm not going to say that. If you're writing like to a Word document, like with Python, right? And so yeah, if you weren't like pickling an object, but if you were, say, had a Word file on your computer and you wanted to add something to it or edit it in some way, you would just use write. You wouldn't write in binary, because Word documents are not in binary, at least not on like the user level. Anyway, so you pass in your parameters. You tell it like what you want, what file you want, and what you want to do with it. And remember, we're writing something here, so this doesn't actually exist yet. So as soon as we run this code, then that's going to create a new file on your computer with this file path. And I believe if you wanted to go to a specific folder or directory, I haven't tested this or tried this out myself, but I believe it's correct. If you want to put this into a particular directory, then you put like the path to that directory and then like the name of the file that you want to write. So at this point on this line, we've just written the new file, but it doesn't have anything in it. It's just kind of like empty space on disk somewhere. So then we call this .dump method onto our pickle object, and we pass in the actual Python object that we want to pickle, and then F is the thing that we want to dump it into. So as F, so we created this file and we basically gave it the variable name F. And so here in our dump method, we're giving it the Python object that we want to dump and where we want to dump it at. And basically this is going to load whatever's in this variable called data object. It could be called fill or whatever, like, you know, whatever the variable name is kind of irrelevant. But whatever Python object is in there, it's going to get loaded into that file. So if I even just had like a dictionary, that's actually a good example, because dictionaries can hold pretty sophisticated information, right? If I wanted to save a dictionary as a dictionary itself and not just like copy and paste it into like a Word document or something hacky like that, you can, I completely lost my train of thought. Where was I going? So you can load like that dictionary object into this file, and so like you're gonna see that if you go to your file explorer and double click on it, it probably won't open it, or it might try to open it in like Atom or VS Code or whatever like code editor your default is set as. But yeah, and I think you also, I could be wrong about this, but I think the way I write import pickle here, I think you have to do that. Like I should technically have that here. I think for every like pickle thing you want to do, you have to import pickle again. So anyway, this is creating that object. Now I can't, at this point, whatever data object is like defined as, so what the heck? Oh, I see. Syntax highlighting for the win. Yeah, so say I have this dictionary. I named it data object, and then I pickle it. I dump it with pickle. I'm not going to be able to, the next time, in the next cell, for example, if I wrote data object again and called it, it wouldn't it would give you like a class error, or it would throw an error basically saying that object doesn't exist. It's undefined. It would say like this, there's no information attached to this variable name that you're passing in. So then you can open it the same way using the pickle library. Instead of doing pickle.dump, you would do pickle.load. And the syntax here is pretty much the same, with the exception that we're going to do RB for read binary instead of a WB for write binary. So that's pickling, and that works with any sort of Python object. Any object in Python can be pickled and saved. It's important to note there's like no built-in security constraints with pickle files, so you really only want to use these from a source that you trust, someone that you know personally, or one that you like made yourself, right? So if some Nigerian prince emails you asking to help you with their SciKit Learn homework, and they need you to open a pickle file with a model in it, probably don't do that. But pickle files are really cool. Like I said, they can be really handy. Obviously, if you have like, you know, really extensive like lists or dictionaries or anything like that, mainly, that's what I imagine would be using them for the most. Or even if you like wrote a cool new type of class object and you wanted to share it with your friends or something. SciKit Learn objects, you can't use the pickle library, but you can pickle them. You just have to use this library called joblib instead. The syntax here is basically identical. You have your file path, exactly what you want to do, read or write. You're assigning a variable to that variable name to that file. It's pretty typical. Most of the time you'll see it just as f. Your dump method, your load method, it's all pretty much the same. Remember, I believe this is also true with joblib. You need to like import joblib after every time you do it. It's also important to note that SciKit Learn objects that have been pickled are typically, you can put any file extension you want here on the end of it, but if you're looking at others and it's PKL instead of pickle, that probably means it's a SciKit Learn object. So just keep that in mind. Again, like your dump, load, all that good stuff. So you create your model and then you pickle it and then you load it with a new variable name. You could use the same one if you want, probably, as long as the original one's not like still occupied, which it shouldn't be. And then you can use that. You see how you're calling your like coefficient and intercept methods on, I think this is like a linear regression, regression model. You can call those same methods on to that variable that you assigned to that model, and it's going to give you some output. This string here is representative of what this print function would print out at you. You can call your like .predict method, and you can pass in certain values to it, and it's going to return its predictions. So you can see that's the formula: y equals 1x plus 1, so 10 goes to 11, 11 goes to 12, 12 goes to 13. The complexity of the model is not the point here. The point is that you can basically, like the way you can save a Word document on your computer using joblib, you can save a model object that you completed. And like what's awesome is that you can reuse that model without having to rerun the entire notebook that you built the model with, which might, for a really complex model using a lot of data, that might actually take a little while, and it wouldn't be very useful other than just looking and going like, oh, how cool it is. So generally when like people deploy models, this is how they do that. They pickle it and then they pass it along to like the software engineers or the backend guys or whoever who implement it into the application. But when you're deploying a model, or when people say that, they're generally like talking about pickling the model object, and so that it can be grabbed and used by other people who aren't data scientists, who aren't going to go through all the pre-processing data, all that stuff. So basically it makes it so that the data scientists can hand it off to the software engineers, and software engineers can use it without having to like rerun the whole model building pipeline like over and over and over again. So that is pretty much it for module 30. It was a pretty quick module. Not quite as fascinating as like the naive based stuff from the last module, whichever one it was before that. But these are really powerful tools that can really help scale your productivity and not just help you get more stuff done quicker, but also share more of your stuff more efficiently with other people. So yeah, that is it for our topic review today. I hope you enjoyed the video or learned something or got the gears turning a little bit. If you're curious about Flatiron School, what it can do for you, I'll have the link below. If you want to check out this notebook or any of my other repositories or any other Flatiron stuff, it's all on my GitHub, also linked below. If you would like to ask me questions directly or just want to connect, my LinkedIn will be linked below as well. And of course, you can leave a comment on the video, like and subscribe, all that cool stuff. So, yep, until next time, keep on coding, keep on learning, and I'll see you with another topic review. I keep thinking I'm forgetting something, but I don't know that I am. Or if I am forgetting it, I'm forgetting it, so I'm not going to remember to say it. So, I'll see you in the next video. Have a good one.